This is the radian version of the unit circle, where we're going to take the equation for the circumference, which is 2 pi r, and apply it to the unit circle. So the radius of the unit circle is 1, so this is 2 pi times the radius, times 1, which is just 2 pi, and that's the unit of measure that we're going to use to show one complete rotation of the unit circle. So we know 0 starts here at 0 and goes all the way around to 360 degrees, but now we're going to apply it starting at 0 radians and going all the way around 2 pi radians. Okay, now if that's 2 pi, and then I decided to only go halfway around the unit circle, well, half of 2 is 1. So this would just be pi, or 1 pi. Okay, from here to here is pi, then half of that, cut it in half, we're at pi over 2. So we're dividing pi by 2 without really dividing or coming up with an answer. We're just leaving it in the fraction form. Cutting it in half again. We take the 90 degrees and we cut it in half, we're at 45 degrees. If we cut that in half, we're at pi over 4. So the pi over 4 is what we're going to use as sort of a stepping stone. We're using that as, if 45 degrees is here, another 45 is 90. If we count by pi over 4 and another pi over 4, that's going to give me 2 pi over 4. Now we usually don't write that, except because it reduces to pi over 2, but we think of it as pi over 2, or 2 pi over 4, so that we do one more of those steps and we get to 3 pi over 4. So there's 3 pi over 4. And if I continue that, I would get to 4 pi over 4. Again, we don't refer to that because this is pi. 4 pi over 4 reduces to pi. But if we think of it as 4 pi over 4, and we do that again, we're down here to 5 pi over 4. And if we kept that going, we'd end up at 6 pi over 4. I'll write that down for just a second. 6 pi over 4. We'll reduce that in a moment. Then this over here would be a 7 pi over 4. And then if we finish that up, it would be an 8 pi over 4. Again, counting by fourths in terms of the half steps all the way around, 8 pi over 4 reduces to 2 pi. Now I put this outside because 2 goes into both of those. That reduces to 3 pi over 2. So I'm going to point this out. The top and the bottom here are the only places that have a denominator of 2. Okay? 1 pi over 2, and then again, if I count by 90 degrees, pi over 2, 2 pi over 2, which reduces, 3 pi over 2, which doesn't, 4 pi over 2, which is 2 pi. Okay. To fill in all the other missing spots, I kind of go back to the degrees again. This is 30 degrees, 60 degrees, 90 degrees. If we take 30-degree increments all the way around, there's 6 steps that we would take in terms of counting by 30. That would get me to 180 degrees. Well, you cut 180 into 30 parts, or divide it by 30. That says that we took 6 steps as I went around. So if I divide that by 6, I got pi over 6, and that's going to be my next unit of measure. So pi over 6 is the is a first stepping stone. If I use that same step, I would end up at 2 pi over 6. But that's really pi over 3. It reduces. Now if I did that again, I would have 3 pi over 6. Again, we don't refer to it as that because it reduces to pi over 2. But pi over 3 allows us to go to 4 pi over 6, which reduces, but then we go on to 5 pi over 6, which doesn't reduce, so we keep that there. And then 6 pi over 6 would be our pi over, or our pi. Now that reduces, if you divide by 2, to 2 pi over 3. You don't really need to know how all these numbers come up. In fact, I'm showing you how that's done. I'm just going to finish this up. 7 pi over 6, 4 pi over 3. This is 5 pi over 3. 7 pi over 4 we already have, and this is 11 pi over 6. So the things that I want to point out to you on the unit circle, in terms of radians, everything in this quadrant here has a numerator of pi, but the denominators are different. The short triangle has a denominator of 6. The middle one has a denominator of 4, and the tall triangle has a denominator of 3. And that's going to be true in every quadrant. If I just focus our attention on the short triangles, I like to call them the bow ties because they kind of look like a bow tie. So if I only look at the bow ties, look at the denominators. Denominator 6, denominator 6, denominator 6, denominator 6. All of the short triangles have a denominator of 6. All of the tall triangles have a denominator of 3, 3, 3, 3, and 3. That means all the middle triangles are going to be consistent too. They're all a denominator of 4. So if we understand that this is going to be 6s here, followed by 4s, and then the tall guys are the 3s, if there was some way of understanding the numerators, we'd be in business. And guess what there is? All of these we already said are pi. So if you see a sign of pi over anything, it's going to be coming from the first quadrant. And you got to kind of look out for that one too. That's not in the first quadrant, but it's right there. It's in the transition from first to second. But if you look at all these in the second quadrant, the numerator is 1 less than the denominator. 2 over 3, 3 over 4, and 5 over 6. So if the numerator is 1 less than the denominator, you know when you're in the second quadrant. When you get down to the third quadrant, the numerator is 1 more than the denominator. 7 over 6, 5 over 4, and 4 over 3. Beyond that, you're getting close to 2 pi. So you've got numbers on top that are, well, much bigger than the denominator. Okay, in fact, almost 2 times as big. In fact, it's 1 unit short of 2 times as big. So if you multiply the bottom by 2 and subtract 1, times 2 is 12 minus 1 is 11. Times 2 is 8 minus 1 is 7. Times 2 is 6 minus 1 is 5. So you've got sort of a way of that you can identify any of the radian measures. Then it's just a matter of identifying the sine and the cosine. So if I look at this triangle here, that this height is 1/2, this distance is root 3 over 2. But if I asked you for the cosine of 5 pi over 6, I'm asking you for the x value. Not only am I asking you for the length, but I'm asking you for the direction. Okay, so the cosine of 5 pi over 6 is negative root 3 over 2. What is the sine of 5 pi over 6? Well, the sine is referring to the y value. The y value is 1/2, and it's positive because it's still going up. Reminder here that the cosine is negative and the sine is positive in that second quadrant. I'll remind you that both of them are negative in the third quadrant, and that over here the cosine is positive and the sine is negative in the fourth quadrant, and they're both positive in the first.